Factoring is definitely something you're going to be tested on.
Yeah.
Can you factor the first one? Hold on one second here. Okay. I think I can write now. Yeah. You know what? Let me just take a minute here and see if this works any better. It might. I've got a problem here with my drawing tablet. I'm not quite sure how to solve it. Let's see if this helps. No. Yeah, it does actually help a little bit. All right, so this is a first order quadratic, meaning the coefficient of the x squared is 1. Those are always the easiest. If the coefficient of the x squared is not a 1, they're harder, a lot harder. So let's make absolutely sure that you can do the ones that are easy, like this one. How do you factor this?
So do you separate the x into both of the parentheses?
Okay, that's step 1. What's second step?
Determine the signs.
What are they?
I feel like they both have to be different, right?
Correct, because otherwise you would not be able to produce a negative 42.
Yeah.
Only with a plus and a minus can you get a minus 42. So what's the third step?
And then do you find the greatest common factor?
No, you find factors of 42
Oh, okay.
that do something. And in this case, they subtract, because of that negative sign right there, to the coefficient on the x term. What is the coefficient on the x term?
1.
Okay, so I'm looking for factors of 42. Now, do you know how to factor a number?
You might have to remind me.
Well, it's actually pretty easy. The way I do it is fairly straightforward. First of all, I always see in other words, you start with 1 and the number. The next thing you do is see if you can cut the number in half. And I can. Well, if I cut that in half, I got to multiply that by 2. 2 times 21 is also 42. Now, can I cut 21 in half? No. But can I cut it in thirds?
Yes.
So I'll cut it in third. Since I cut it in third, I got to multiply the other one by 3. Now, can I do anything with 7?
No.
Can I do anything with 6? Can I cut 6 in half?
Yeah.
Got to double 7. And so it goes until you've discovered all of the factors. That's pretty much the process. If you can cut either side in either halves or thirds or fifths, that's what you do. So we're looking for factors of 42 that subtract the 1. Which ones are they?
The first one. The first pair.
This one? Those factors don't subtract to 1. We need factors. In other words, our factors are 1 and 42, 2 and 21, 6 and 7, and 3 and 14. Which ones subtract to 1?
6 and 7?
Yeah. Now, that's the first 3 steps accomplished. One last step on this one is we have to make sure we put the right number with the right sign. And the rule is you take the larger number, 7, and you put it with the sign of the middle term, which is negative. So the 7 goes with the negative. 6 goes there. You want to do a quick little check. We don't have to check the x squared term. We know that's right. We don't really have to check the minus 42. We know that's right. But if we look at the inside, that's plus 6x. And the outside, that's minus 7x. Combine them together, you get the middle term, always. So, if your life was dependent on getting this problem right, you would do this last step. Now, when you're taking a test and speed is a factor, you might not have time to do that last check. Okay? All right, let's go back to your paper and look at 28. First of all, on 28, what's the first step?
Oh, okay.
Well, let me suggest a first step. Whenever you see a coefficient in front of the x squared term that's not 1, like in this case it's 6, see if you can factor out a 6. Because if you can, it makes the problem so much simpler. In other words, always try to do a greatest common factor as your first step. Unfortunately, here it's not going to work because 23 is a prime number. So we are not finding anything that divides into 23. So we're going to have to deal with this as a harder quadratic. But the first step is really kind of the same. What's the first step?
Can you split the 6x squared into 2?
Yeah, how can I do that?
Put 3x squared in both of the parentheses.
Well, 3x and 2x. In other words, the number one thing they have to do is multiply together to give you 6x squared.
I thought you could just split it in. Okay.
Yeah, and you never split it up x squared and no x. In other words, you are always splitting up the x's.
Yeah.
Now, there's actually another way to split it up. I could do 6x and 1x. That's what makes these harder. There's a lot more combination. Okay? But what I generally tell everybody is to try the two factors that are closest together. And 3 and 2 are closer together than 6 and 1. Okay? It may not be the right answer. At this point, I don't know. These are difficult because they are trial and error. However, second step is still the same. What's the second step?
To find the signs.
Both signs. Not one of them, both of them.
Yeah.
What are they?
Are they both negative?
Well, they're both the same because you can't produce a plus 20 unless they're the same.
Oh, okay, yeah.
And
So
if
they're
you
both
know whether they're negative or positive, look to the middle term. The middle term is positive, therefore they're both positive.
okay.
Now, you kind of have to throw those rules out the window. We can no longer say factors of 20 that add to 23. It doesn't work for these harder quadratics. We certainly want factors of 20. Over here on the left, let me write them. What's first step? What's the next factors?
Oh, sorry, I didn't see it.
Can you cut 20 in half? Always start there. Okay, so that's 10. Since I could cut it in half, I got to double that one. And you cut it in half again.
5 and 3.
5, so I got to double 2. In other words, if you can cut it in half, you have to double the other one.
So, it's 4.
You don't just count up 1, 2, 3. You see whether you can cut it. Okay, now 5 is a prime number, so I can't cut it in half. I can't cut it in thirds. I could cut it in fifths, but then I get back to what I started with. Same thing with 4. I can cut 4 in half to 2, but that just gives me another 2/10. And so it doesn't give me another unique set of factors. So those are the only factors of 20. Now, the other thing I always tell people is when you are doing trial and error, start with those two. So just stick 5 there and 4 there. Doesn't matter how you pick them. Now, the important thing here is, again, we're trying to create the middle term. And the middle term always comes from the inside and the outside, what I call my double smiley faces. Well, if I do that, that gives me 10x. 4 times 3 is 12x. That adds to 22x. Well, that doesn't work. So let's swap them. Let's try 4 there and 5 there. Now what do we get? We get 8 and we get 15. 8 and 15 is 23. Bingo. We found our answer. Because the middle term is 23. In other words, the name of the game here is just keep trying combinations. And there's a lot to try here, because if none of these 3 factors worked, I got to go back and try 6x and x, and then repeat the whole process. So these problems are quite a bit more difficult, but use this not as a check, but in solving the problem. In other words, without doing my double smiley faces, I can't really solve the problem. In the first problem, I did the double smiley faces just to check the solution to make sure I was right. But in this one's a little different. In this one, it's an integral part of solving the problem. Okay? And the key is, if 4 and 5 hadn't worked, either in this order or the other order, then I'm going to try 10 and 2. And then I'm going to try 20 and 1. If none of those work, I'm going to go back and I'm going to try 6x and x, try 5 and 4 again. And that's the way it goes, is you have to kind of try all possible combinations. All right, let's go down to 29. Now, when you are factoring, always remember to check, first, is there a greatest common factor?
We're on 29, right?
Yeah. Second, is it difference of perfect squares, dopes? If it is neither of those, then you go straight to your parentheses, your factoring. The first two are factoring also, but what I call step 3 is when you factor it like that. Okay? In other words, what we had to do on 27 and 28 is step 3.
Okay.
29's different. Can you factor out anything? Is there a greatest common factor on 29?
Is it like 6 or 7? Or...
Nope. None of those numbers divide into 64.
Oh, yeah, you're right.
So, and there's really only, in other words, 3 is the only thing that divides into 9 or 9. And since neither 3 nor 9 divide into 64, then there's no greatest common factor.
Oh, yeah.
About dopes. Whenever you see something that looks like difference of perfect squares, it most likely is. In other words, you're looking at perfect square numbers that are being subtracted, right? 9x squared is a perfect square number. So is 64y squared. So if you think you are looking at difference of perfect squares, The answer is really easy. Here, let me show you. If I have a squared minus b squared, if I want to factor that, it's always the square root of a squared minus the square root of b squared times the conjugate, a plus b. Piece of cake. When you're factoring difference of perfect squares, you do it a little different. You don't find both factors at once. You solve for the first factor, a minus b, and then you know the next factor automatically is just the same two things, only with a different sign.
Okay.
Okay? So the way I got that was by taking the square root of a squared. So the way you're going to do this one, you're going to take the square root of 9x squared, because 9x squared is a perfect square. What's the square root of 9x squared?
3.
3 times 3 is 9. In other words, it's not 3. You're close. It's about 3x.
Oh, yeah.
3x times 3x is 9x squared. How about the square root of 64y squared? Square root of 64.
32y.
No, that's half of 64. You're looking for a number that multiplies by itself that gives it 64. Experiment. Think of some numbers.
Oh, yeah, it's 8.
It's 8, right?
Yeah.
What's the square root of y squared?
8.
That's the square root of 64. What's the square root of y squared?
Just y.
Yeah. So this is minus 8y. 8y is the square root of 64y squared. So we've got the first term. What's the second term? I don't need to do any math. What is it?
Is it just like the same thing but positive on the other side?
Exactly. It's 3x plus 8. It's the beauty of difference of perfect squares. Is it's pretty easy to come up with the first term, and then it's really easy to come up with the second. It's really helpful if you know your perfect square numbers for problems like this and others, especially when you're simplifying radicals. If you're simplifying radicals, you really have to know your perfect square numbers. So tell me what they are. What's 2 squared?
4.
What's 3 squared?
9.
4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64.
9 squared?
81.
Remember those and be able to recognize them when you see them, that that's a perfect square number. In other words, when you see the number 49, you should be thinking that's 7 times 7. Square root of 49 is a whole integer number. Okay? All right, let's go on. 30. Again, think about that list of priorities when you're factoring. First thing is greatest common factor. Can you do that here? On number 30. Start with the number. Can you factor out a number? In other words, always start with the numbers and then the variable. Don't do the whole thing in one bite. Can you factor out a number?
I mean, I think you could factor out 12.
No. In order to factor out 12, you'd have to be able to divide 3 by 12. Can't do it. In other words, whatever number you come up with as a greatest common factor has to divide into each term evenly. So what's the greatest number that can divide into each term?
3.
What's the greatest letter that can divide into each term?
A.
Okay, there's your greatest common factor. What are you left with?
12A squared minus
Hold on.
63.
What you're left with is take each term and divide it by 3a. That's what it means to factor out a 3a. To take a greatest common factor out, you're going to just divide all three terms by 3a. So what is 3a cubed divided by 3a?
1.
1 for the numbers, yes. What for the letters?
1A.
What's a cubed divided by a? Remember your rules of exponents. Same base, division. What are you going to do to those exponents?
Subtract them.
So what is it?
So it's 1A squared.
So it's just a squared. We don't need to write the 1. Now, before you go to the next term, multiply those two back together again to make sure you did it right. Did you?
Yeah.
And that's definitely when you should do it. You do not want to wait until you get to the final problem, the final answer, because you won't know where you made a mistake if you've made a mistake. You want to find out on the fly. Okay? What's the next term? Divide 12a squared by 3a.
4A.
And finally, the last term, 63 divided by 3 is 21.
Yeah.
And what letter goes with it?
A.
Nope, just 21.
Oh.
In other words, 63a divided by 3a is just 21.
Yeah.
Okay? Now notice what happened. We started with a really hard a cubic, not even a quadratic. It was a cubic that would have been extremely difficult to factor. But because we were able to take a greatest common factor out, now we're left with an easy quadratic. In other words, it's easy because its coefficient is 1. So let's factor that quadratic that's currently in parentheses. In other words, this quadratic right here.
So just put A in both the parentheses.
Second step.
Find the sign. So they're both different.
Okay. As long as it's A in both, then it doesn't matter if I write plus minus or minus plus. It's going to be the same. Okay? And that's important because when you get higher level, like 28, that's not true. If the signs had have been different, then plus minus is not the same as minus plus. But in this case, it is. So what's the third step?
Factor out.
Factors, verbalize it for me. Factors of 21 that do what?
That subtract a 12.
Not the 12. What's in the middle term?
12A.
No, we're dealing with what I've got circled here. We're not dealing with the original problem. We already changed the original problem by factoring out a 3a. So now we're factoring a squared plus 4a minus 21. So it's factors of 21 that do what?
Subtract to 4a.
Not to 4a, to 4.
Yeah.
You're only dealing with the coefficient. So what two numbers that are multiply to 21 and subtract to 4?
7 and 3.
Good. Which one goes with which sign? And it does matter.
So the biggest one goes with the sign of the middle term.
Perfect.
So 7 would go in the first one.
And the 3 goes there. Now, again, if speed is a factor, I'm done. I'm not going to check this. pretty confident that it's right. If you had time, somebody had a gun up to your head and said, you know, you're only going to live if this is correct, you would definitely check it. In other words, you would multiply these three factors back together again to see if you get the original problem.
Yeah.
Okay? All right. Let's go on. That was a good one, actually. 31. Is so hard that I'm tempted to not do it, but the fact that it's so hard, I bet I can do it on the first try. Just watch me try it, and you kind of get the idea. Okay? First of all, I got to split up the 35 AC. Well, I'm going to try 7A and 5C. Does that multiply together to give you 35 AC?
Yeah.
Okay. Next, I'm going to take the last term, and I'm going to try to split that up, and I'm just going to guess and call it 3B and 5C. And I know the signs are the same, and all my signs on the middle terms are negative, so I probably have the sign wrong. So let me go back and make it negative and negative. So it's, excuse me, 1 second. So it's probably negative 3B and negative 5C. Okay? So that would be my first guess as to a solution. Now, let's see if that's what we get when we multiply those two numbers together. I'm going to do the F of FOIL. You know FOIL?
Front.
Or I prefer calling it every term by every term. If I'm going to take this answer that I have and multiply it back together again, I'm going to do every term times every term. Okay? The first term gives you 35 AC. See that?
Yeah.
Second term gives you minus 35 AC. Well, already that doesn't look good. We need a B and a D in here. Gosh. You know what? Since we are pressed for time, I'm going to skip over this. This is an extremely difficult problem. I'm not even sure I know exactly how to do it, but it would be a lot of trial and error. I would just keep trying different numbers and letters until I'm able to produce that. That's basically the name of the game. I tried a couple and I didn't come anywhere close to producing that. Don't want to use our entire session on this because you're only going to get one of these problems. You're definitely going to get a bunch of those problems. You're going to get a bunch of those problems. You're going to get some of those. You're going to get one or two of those. You're only going to get one of those at most. So let's work on stuff you're more likely to get.
Okay.
Okay? 32. We have talked about the difference of perfect squares, right?
Yeah.
A squared minus b squared always factors into a minus b times a plus b. Well, there is no sum of perfect squares. A squared plus b squared does not factor. However, there is a difference of perfect cube. And there is also a sum of perfect cube. First of all, the difference, the first term is always a minus b. One way to memorize it. When you're dealing with cubes, the second term is always a squared, opposite sign, plus ab plus b squared. And sum of perfect cubes, also factors, similar. First term is a plus b, same sign as what we're dealing with. Second term is just like above. It's a squared opposite ab plus b squared. So that's how you factor the difference of perfect cubes and the sum of perfect cubes. You with me?
Yeah.
Problem 32, what is that?
That would be the sum of perfect cubes.
Okay, so we're going to factor it. In this case, a is what? You're going to have to take the cube root of 8x cubed. That's what A. A is the cube root of that.
That would be 2x cubed?
It's 2x.
Oh, okay.
In other words, 2x times 2x times 2x is 8x cubed.
Yeah.
Okay. What's b? B is the cube root of 27. In other words, b cubed is 27, correct?
Yeah.
So what's the cube root of 27? Just pick a small number. Is it 2?
No.
Is it 3?
It might be 3.
It is 3.
Okay.
Cubes go up really fast. 4 cubed is 64. 5 cubed is 125. So when you're taking cube roots, they're never going to say what's the cube root of 28. It's always going to be a perfect cube number. Okay?
Yeah.
So we got the first term, correct?
Yeah.
What's the second term? We got to reproduce that. What's a squared? First of all, what's a?
2.
X. A is 2x. So what's a squared?
4x.
4x squared. In other words, you have to know what a and b are. Okay, we know what a and b are. We just wrote it. A is 2x, b is 3. So a squared is 4x squared. What's a times b?
12x squared.
It's 2 times 3.
Oh, 6.
So 6x is ab plus, what's b squared?
9x.
Yeah, and that's how you factor the sum of perfect cubes. If it was the difference of perfect cubes, we would have used that formula. And notice that these are actually not that hard to memorize. Notice that starting with the difference of perfect squares, the first term is always a, the same sign, minus b. Second one, a minus b. Third one, a plus b, because we're doing the sum of perfect cubes. So the first term always matches the sign. And the second term always is the opposite sign of the first term. In other words, that's opposite that, that's opposite that, and that's opposite that. The only thing that's a little difficult is this is a squared, ab, and b squared. But that is the answer at the bottom to problem 32. And in case you're wondering, the quadratic that you're looking at, 4x squared, That's never factorable. So don't even bother wasting your time trying to factor it. In other words, you could spend 10 minutes trying to factor that because there's lots of different possibilities. There's 4x times x, there's 2x times 2x, there's 9 times 1, there's 3 times 3. It would take me 10 minutes to figure out that that was not factorable. So that's why I'm telling you is that second term is never, ever factorable, which means it's reduced to its lowest form in this form right here. You can't factor it down further. It's called an irreducible quadratic. All right. Let's go to, I think, yeah, there's more problems on this side. All right. Well, they didn't make these easy.
Nope. Never do.
33. We do not have a formula for difference of perfect fourths. However, we can view this as difference of perfect squares. You see why?
Yeah.
So how is this going to factor? If you view it as difference of perfect squares, what's the first term going to be?
A squared.
Good. Minus what?
Minus 9.
9b what?
9b squared.
Okay. What's the second term got to be? Just the conjugate. Don't need to figure anything out. It's the same two things, only with a plus sign.
Oh, okay. So, yeah, just
A squared plus 9b squared.
Yeah.
Okay. Now, I can factor that a little bit more. Let me do it this way, though. That other way really does not work at all. I'm just going to have to go out and get a new drawing pad, I guess. So here's where we're at. We're at a squared minus 9b squared times a squared plus 9b squared. Notice the second term is the sum of perfect squares. Can I factor that?
Yeah.
No, you cannot. There is no sum of perfect squares. You can factor sum of perfect cubes, you can factor sum of perfect fifths, but you can't do sum of even numbered. Square is an even number, so there's no breaking that down. First term, however, is a squared minus 9b squared. What is that?
Wait, what?
This first term right here,
Yeah.
that's also difference of perfect squares.
Oh, yeah.
So I can break that down. What is it?
Would it be a minus 3b?
Good, very good. You're getting this. What's the second term?
Just the same thing with the plus sign.
Tell me what it is.
A plus 3b.
Okay. And that's your final answer. Because I cannot break down the sum of perfect squares. That just stays like it is. In other words, we can factor this down to three things only. Okay?
Yeah.
All right. So sometimes you have to see things and realize that, that looks like the difference of perfect fourths, but I can treat it as the difference of perfect square. Now, 34. What are we going to do with 34?
So
What's the first thing you're going to try to do?
try and factor out 3x squared.
Well, not 3x squared, because you can see an x squared, an x, and a no x, right? So there's no way I can factor out a variable.
Yeah.
I might be able to factor out a number, and the only number it could possibly be would be 3.
Yeah.
Is 43 divisible by 3?
Yeah.
No. I tell you how you can tell if a number is divisible by 3. Add up the digit, and if the number that you get is divisible by 3, then the whole number is divisible by 3. So what are 4 and 7 add, or 4 and 3 add to?
7.
That's not divisible by 3, therefore 43 is not divisible by 3. It's a neat little trick to see whether a number is divisible by 3.
Yeah.
It works with 9s also. Only numbers that add up to 9 are divisible by 9. Notice 18 adds up to 9, 1 and 8. 27, 2 and 7 add up to 9. All of those are divisible by 9. Okay, so 43 is not divisible by 3. So there's no greatest common factor. Second thing, is it difference of perfect squares?
No.
Now, if there's 3 terms there, it's never going to be difference of perfect squares. Okay, you get difference of perfect squares when there's just 2 terms like that, and they're being subtracted. So difference of perfect squares like 38. Can you see 38 at the bottom?
Yeah.
I recognize that immediately as difference of perfect squares, because first of all, there's subtraction going on, and I can split it up into x squared minus 4 times x squared minus plus 4. But let's get back to 34. I don't mean to jump around like that. 34 is a harder quadratic. That doesn't mean it's not doable. Just means it's going to be a little harder. First step.
So can you divide the other 2 by 3x?
No, you can't do it. In other words, 43x is not divisible by 3x
Yeah, you're right.
squared. So we've already ruled greatest common factor out. So the only way to do this problem is by factoring, the normal way of factoring. It's just going to be harder. But now the first step is to split up the 3x squared. How am I going to split that up? What 2 numbers are going to multiply together to give you 3x squared? Remember, you always split up the x squared. So you know that it's an x and an x. That multiply together, back together to give you 3x squared?
Is it just like 1 and 3?
Yep.
Oh, okay.
That multiply together to give you 3x squared.
Wait, what?
The question, when you split it up, the very first question you have to ask yourself is, does it multiply together to give me what I started with? Does it? Is 3x times x 3x squared?
Yes.
Then we did it correctly. Second step, both signs.
They are both going to be different.
No, remember, if they're different, you cannot produce a plus number.
So they're both positive, sorry.
No, if they are the same, yeah, my bad. They're both the same. That's the only thing you can see when you look at the plus sign in front of the 40.
Yeah.
Is that they're either plus plus or minus minus. And the way to figure it out is look at the sign of the middle term. That'll always tell you. which one it is.
Oh, okay, so they're
So
both
it's
negative.
minus minus. Now again, we're back to factors of 40. Let me go over here on the left, break 40 down, 20 and 2, 10 and 4, 5 and 8. I think that's it. Which two am I going to try for starters? Always try the two closest ones.
5 and 8.
Yep. And I'm just going to randomly try it. 5 there and 8 there. Now I'm going to see if that gives me the middle term. Does it?
Yeah.
No, not even close. You got to do the double smiley faces. In other words, the middle term comes from the inside and the outside. That's how you get the middle term. It's the O and the I of FOIL. Well, that would give you minus 5x and minus 24x, which is only minus 29x. And I've got my biggest number multiplying the 3. So clearly my factors are not going to be 5 and 8. So what's the next one to choose?
10 and 4.
Yep. Let's put the 10 with on the side that's going to get it multiplied. In other words, get a bigger number faster. So I'll put a 10 there and a 4 there. What does that give me for a middle term?
$34x.
Yeah, that's not right either, huh?
No.
Okay. So let me try 20 and 2. What's that give me for a middle term?
$62.
Too big. So let me swap those terms. Let me try the 20 on the left and the 2 on the right. That gives me 26, right?
Yeah.
So that's not right. So here we are left with the only thing left to try, which is 40 and 1. Well, clearly, if I put the 40 on the far right, it's going to multiply the 3, right?
Yeah.
That's going to give me 120, so let's not even try that. But let's try it there. When I put it on the left, it only multiplies the 1x.
Yeah.
Now what's my middle term?
Negative 43.
Perfect. That's our answer. That's how you have to do those harder quadratics. It's a total trial and error. Notice that I tried those, couldn't find a solution, couldn't find a solution, couldn't find a solution, found a solution. If 40 and 1 didn't find a solution, then what's my next step? If I can't factor it, what's the final solution when you can't factor something?
0.
The quadratic formula.
Oh, okay.
Quadratic formula will always give you the answer. It won't necessarily be in nice, clean, whole numbers like this, but it'll give you the answer. It's just your answer might be like square root of 23, stuff like that. But this is the way to do it. They probably aren't going to give you any in a section called factoring. They're not going to give you one that doesn't factor. That would be hitting below the belt if they did. Just because people would spend 15 minutes trying to factor.
Yeah.
So let's have a shot at 36. I think I can actually, let's do 35. The reason is that I'm quite certain you're going to get a problem like 35 on the test. What is 35 called? Is that a quadratic?
I think so.
No. Quadratics are all squared.
Oh, yeah, you're right.
34 was a quadratic because it was x squared, there was an x, and then there was a number. There's an m cubed, an m squared, an m, and a number. This is a whole order of magnitude harder than quadratics. However, there is a very, very small percentage of cubics that you can solve by what they call grouping. Familiar with that term?
Yeah-ish.
Okay. Let me explain how it works. You can solve a cubic by grouping only if one condition is met. Coefficient of the first two terms has to have the same ratio as the coefficients of the second two terms. Well, the first term has a 1, second term has a -4. Third term is a -3, last term is a 12. Are those two ratios the same?
Yes.
Therefore, we can solve it by grouping, which, believe me, is so much easier than the alternative. They have not taught you yet how to factor cubics. You won't get that until pre-calc. What they do teach you how to do is solve the ones that you can be grouped. Okay, I'll go through it with you real quickly because we're running out of time. But here's what you do. You group the first two terms together. Put parentheses around it. And then in other words, the only thing I've done is group stuff. Notice that I haven't changed anything. I've just put parentheses around the first two terms. Notice what I had to do in the second term. I had to change it to a -12 from a +12.
Yeah.
Now remove the parentheses and tell me if I have the same thing that I started with.
Yeah.
That's what's important.
Oh,
It
wait.
doesn't matter that I changed it to a -12. What I have to have is the same thing I started with. That's why I put in a -12 instead of a +12. Because the minus sign that is in between the two parentheses, that thing gets distributed to both terms on the right. So I have successfully grouped it. Next thing I'm going to do is take out a greatest common factor from each part. Well, that would be m squared, leaving m -4. You with me?
Yeah.
I'm going to do the same thing over here. I'm going to factor out a 3, leaving m -4. And now focus your eyes on that line right there. Because we're about to do something you've probably never ever done before, which is to factor out a binomial term. I'm not going to factor out an m. I'm not going to factor out an m squared. I'm going to factor out an m -4. Do you see how I can do that? In other words, both of these terms are divisible by m -4, are they not?
Yeah.
Therefore, I can factor out m -4 in parentheses. And what am I left with?
M +4?
M squared -3. In other words, when I divide that term by m -4, I got m squared.
Oh, yeah.
When I divide this term by m -4, I get just -3. So the very bottom line is the answer. It's m -4 times m squared -3. Now, I can't factor the second part because that's not really the difference of perfect squares. It's close. M squared is a perfect square, but 3 is not a perfect square number. However, I'm not sure what your teacher has taught you. Doesn't actually have to be difference of perfect squares. It's still factorable. It factors to m minus square root of 3 times m plus square root of 3. So even when it's not difference of perfect squares, you can still apply that factoring rule. In other words, take the square root of the first term minus the square root of the second term and multiply it by the conjugate. That's all I did. Now, whether or not your teacher wants you to take that last step that I have at the top, I don't know. She may not have taught it that way to you. In other words, that may be something you don't get until pre-calc, where you can actually factor things that are not difference of perfect squares. There's a reason they make up that name, difference of perfect squares, is so that they can teach people it in Algebra 2. But from a math point of view, it doesn't have to be perfect. It's just difference of squares.
Yeah.
So the bottom line where I have the arrow pointed, that may be the answer that they have. If you have an answer sheet at the back. Do you have one?
No.
Okay. So, but I'm guessing that that's probably the answer they want. Maybe this. It all depends on whether they've taught you that you can actually do the difference of perfect squares things when it's not perfect squares. All right. That's probably where we need to end. We just make a mention on 38. 38 is exactly the same as 33. It's a quartic, meaning a fourth degree equation, but for all practical purposes, I can treat it as the difference of perfect squares. So how's that going to factor?
You split the two x's.
So what is the factors?
So it's x squared, and then in the first parenthesis it's minus 4, and then next it's plus 4.
Good. Good. And then let me just finish that problem. In other words, the first step is going to be x squared minus 4, correct?
Mm-hmm.
Second one is x squared plus 4. And then I can apply the difference of perfect squares to that first thing again. How does that factor?
So it would be, in the first one, just x minus 2, and then the next it's x plus 2.
Perfect. And that's usually the way with problems like this, is that one of the two resultant terms, you're going to be able to do it a second time. Again, there is no sum of perfect cubes, so I cannot break down x squared plus 4. But I certainly can break down the x squared minus 4.
Okay.
All right. Maddie, I will let you go. And it does feel to me like you're making a little progress. Unfortunately, there's so much to cover that I don't know. I don't know how we solve that problem.
Yeah.
There's like 6 hours of material to cover in these 6 pages you sent. And some of them are pretty hard. You can see that some of them are really hard. 34 was really hard. It took us 10 minutes to do 34 just because the correct answer was the last one we got to.
Yeah.
So anyway, good luck on your test if I don't have a session with you. I think we actually have a session scheduled for next week. So we'll have some more time to go over this, and we can start on 37 next week.
I actually have a final review packet I'll probably send your way.
Okay, that's fine. I don't, we have so many problems that we're not lacking for problems to do. But
yeah,
certainly, if he gives you a final review packet, we should work off of that.
Mm-hmm. Yeah, I'll send
Most likely to be like what the test is going to be. But I
Yeah.
suspect it'll be very similar to what we're working on here. This looks to me like review material for a final for Algebra 2. Exactly what it looks like. All of it put together. All right. Maddie, you have a good week. I'll talk to you next week.
Yeah. Have a good night.